Hi everybody, this is the notes for Algebra 2 Trig, section 2.3, Intro to Functions. All right, so what we're talking about is basically just relating x's and y's. The first thing is called a relationship, and that just basically means you can match up an x value to a y value, and that's it. There's no rules about them. It's just a relation is x to y. You can just pair them up. It's like points. A function is something specific. It is a relationship, so you're matching up x's and y's, but the key thing, as it's highlighted in yellow, the first variable, usually x, is paired with exactly one value of the second variable, y. Okay, usually y. And so what that means is one x value can only go to one y value. That's what makes it a function. Okay, so you're still relating x's and y's, but to call it a function, you got to have this in place. One x goes exactly with one y value. So functions can be displayed as equations, as a graph, as a table like you're seeing here. Lots of different ways to view a function, but we're still looking for the same thing to say, yes, it is a function. And that's what we want here in this example. In part A, does this table represent a function? And so what you're looking at is, really, do you have the same x value going to different y values? So we got an x value of 2, 4, 6, and 8. Those are all different x values. This is all fine. It's just 2 goes to 2, x value of 4 goes to a y value of 3, x value of 6 to a y value of 4. It's perfectly fine. There's no one x value going to two different y values. So this is a function. All right, part B. Again, same idea. Is this a function or not? So looking at these first two x values, it's the same x value. So that's 3. X value 3 goes to y value 4. X value 3 goes to y value 5. That is a single x value going to two different y values. A function can't have that. So this is not a function. All right. Again, in order for it to be a function, one x value goes to exactly one y value. If you got to go into two different y values, not a function. And so that kind of leads right into the vertical line test. Vertical line, if you recall from chapter 1, when you have a vertical line, the equation is x equals a number. So we're looking at, when you're dealing with a vertical line, you are looking at a single x value. So the actual vertical line test, it says every vertical line intersects a given graph at no more than 1 point. Then the graph represents a function. Vertical line is your x value. If it crosses the graph at more than 1 point, you got to go into two different y values. Where the x value crosses, where that vertical line crosses the graph, that's a y value. All right. So this is the definition. Sometimes this is an easier way to think about it. You have a vertical line. If it crosses the graph more than once, it's not a function because that one x value is going to two different y values. Functions can't have that. So it says if every. I kind of like to think if any. It's just a little bit easier to think about it. So looking at this graph here in part A, you just got a parabola kind of shape. It's an upside down parabola. Is this a function or not? And so what you do is just think, can I draw a vertical line anywhere and have it cross more than once? Crosses only once. Crosses only once. Crosses only once. Okay, that's going to happen everywhere. So every single x value, it only crosses the graph once. That means we're matching up one x value with exactly one y value. That makes this a function. Part B, we draw vertical lines, crosses once, over here, crosses once. But when we get to this right here, this part of the graph is vertical. So what we have is an infinite number of points, infinite number of y values. This is a single x value. It's crossing the graph at lots of points here. That's one x value too many y values. Can't happen. And call it a function. You can't have that and call it a function. It's still a relationship, but you just can't call it a function. All right, that's the first part. The second part, we'll expand on some of this stuff.